Two water containers, one with a balloon at the bottom, the other with an iron ball hanging above. Which way do you think the balance will tip? Let's first look at this example. There's a scale with a wooden board on it, and you're standing on the board. Now, if you bend down and pull on a handle with all your strength, do you think the scale's reading will drop? Of course not. If the reading decreased, it would mean you lifted yourself up. That would imply that if you were strong enough, you could pull yourself off the scale and even fly freely in the air? That's obviously unrealistic. No matter what you do, the board will stay on the scale. The scale's reading will be just as if you were standing on the board directly. There will be no change at all. Likewise, a balloon tied to the bottom of a glass won't lift it. Its weight is the same as if it were just floating on the water. Now, imagine a balloon floating on water. Since an iron ball is heavier, if we slowly change the balloon into an iron ball, the whole ball will get heavier, begin to sink gradually, and the scale's reading will rise. Once the balloon is transformed enough, it will settle in the middle of the cup, floating and staying still in the water. Now, we set up a stand and tie the balloon to it with a string, ensuring the string is perfectly adjusted, not too loose or too tight. As the balloon keeps changing, the string will tighten and support the extra weight, so the scale's reading stays the same. The small ball will stop sinking any further until the balloon fully transforms into an iron ball. We can compare the different states of the small ball and the beaker. The scale reads the same whether the balloon is at the bottom of the cup or floating on the water's surface. A small part of the balloon becomes an iron ball but still floats on the water. The scale reading when the balloon is half iron and half balloon, suspended in the water. The value is equal to when it is completely turned into an iron ball and hung by a string on the stand. In short, the weight of the cup with the balloon tied to the bottom matches the weight of the cup with the iron ball hanging from the stand. So, to answer the video's question, the balance tips right. There are similar questions, such as putting a jar on a scale and letting a bee fly in when you open the lid. The bee hovers inside the jar. So, once the lid is closed, will the scale reading be higher, lower, or the same as the empty jar? And what happens if the bee flies for a bit and then lands? Imagine the bee is now hanging inside the jar with a balloon. How does this compare to the weight of the jar when the bee was flying? Let's think about it this way. There's an empty jar on the scale and a bee flying steadily nearby. Since its wings flap downward constantly, the wind pressure on objects below lets the bee hover. When the bee flies into the jar will feel the wind's pressure, raising the scale reading regardless of how high the bee flies. As long as the bee hovers, the wind's pressure on the jar's bottom remains, even with the lid closed. The bee has to keep pressing against the jar to hover. If it stops, it will drop inside. Thus, the scale will show a higher reading than an empty jar. Now, picture the bee being lifted by a balloon. A balloon lifting a bee doesn't affect the objects below at all. Imagine a hot air balloon flying over your head. You wouldn't feel any force. So, whether the balloon is above the jar or inside it, as long as it floats, it won't exert pressure on the jar. Even if the lid is closed, this still holds. So, the jar with the bee on a balloon weighs the same as an empty jar. It's lighter than the jar with the bee flying inside. Many of us puzzled over this as kids. Which weighs more, a pound of cotton or a pound of iron? Can you answer it now? Don't forget to like, comment, and subscribe.